The water molecules found on Earth can come in different forms, and those forms are called water isotopes. In Antarctica, scientists found a relationship between the mean annual air temperature and the water isotopic composition of precipitation and snow samples. They have applied this relationship to the water isotopes measured in ice cores to reconstruct past temperatures. In reality, it's not that straightforward because the relationship changes through time, is biased, and is affected by other physical processes in the water cycle. One of the processes responsible for the changes of the isotope temperature relationship through time is the origin of the moisture that precipitates onto the ice sheet. Indeed, the climatic conditions at the evaporative sources, as well as the pathway that the moisture takes to get to the ice sheet, both contribute to the final water isotopic composition in ice cores. And this can change depending on the climate, for example, due to different sea ice extent, different atmospheric circulation, or the frequency of extreme events. The atmospheric temperature controls the final water isotopic composition of precipitation, so the atmospheric temperature is only recorded during precipitation events. But snow doesn't fall continuously all year round on the ice sheet. Besides, most of the accumulation of snow comes during few but large precipitation events, which are often associated with warmer temperatures than usual. This means that the water isotope record found in ice cores represents these warm periods of precipitation, and this biases the reconstruction of the mean annual temperatures at the ice core site. To reconstruct atmospheric temperatures from ice cores, we need to assume that the water isotopes from the precipitation are not modified between snowfall deposition at the surface and transformation into ice. But this is not the case, especially at sites where the accumulation of snow is very low, such as the high Antarctic plateau. Between precipitation events, the surface of the ice sheet is exposed to the atmosphere and affected by physical processes such as wind redistribution, sublimation of snow or condensation of the atmosphere, and diffusion of water molecules inside the snow. These processes modify the water isotopes before the snow is transformed into ice and affect the relationship between water isotopes and temperature. In the end, the water isotopes found in ice cores are the result of a chain of processes that need to be understood and studied. Climate models and field measurements help scientists to understand all the mechanisms behind the formation of water isotopes and eventually help to correctly use water isotopes to reconstruct the past climatic conditions. I am part of Deep Ice because I am eager to understand how our climate works and also passionate about polar regions and the Antarctic continent.